Hello students, today we are going to see about the topic called what is assembler directive. Before move on to the topic called assembler directive, we must know what is assembler. Assembler is nothing but which will read the assembly language which is written by the user and convert into a machine code in order to the machine to perform uh, the process which is required by the user, because machine only is going to do the process, but user who is writing the program doesn't know the machine language. So in order to convert that assembly language means nothing but move move a comma b or MBI A comma 20, like that. These are all called as assembly language. This assembly language is not understandable by the machine, so we need a mediator like assembler which will convert that assembly language into a machine language so that the machine can perform according to the user requirement. So we need to give a direction for the assembler, how the instructions has to be converted into a machine code and how much memory space it will take that particular instruction, like LDA 4500, SCA 4500. These are all called as 3 byte instruction. MVI C comma 20, this is a 2 byte instruction. Like that, it will give you a space for a particular instruction, 1 byte, 2 byte, or 3 byte. That is what I have mentioned as a third point. Also, it is allocating memory space according to the various assembly directive codes. So using assembler directive, we will be giving a direction for the assembler to perform a task. Then now we will see what are the various assembler directives types are there. First type, data declaration directives. In that, various classifications are there. DB, defined byte; DW, defined word; DD, defined double word; DQ, defined quad word; DT, defined 10 bytes. So in this, what is the use of this DB, DW, DD? In the program, we will be mentioning, for example, let us take first example, S1DB78H. H means hexadecimal. 78 is nothing but we all know that it's an 8-bit number. So in order to mention that 78 is a 8-bit number to the assembler, we will be mentioning DB. DB means defined byte. Byte is nothing but 8-bit. So that 78 is nothing but a 8-bit number. We have to mention to the assembler that 78 is a 8-bit number, which will be kept in the segment 1. Let us take the second example. In the second example, value is given as 7879. That means it is a 16-bit number. A 16-bit number, otherwise called as 2 byte, otherwise called as one word. So, in order to mention it is a one word, S1, segment 1, segment concept and all, I will explain the latest slides. S1, nothing but it's a segment. Segment 1 consists of a 16-bit number, nothing but one word. That is why I have mentioned defined word, DW. Let us take a third example. If you have understood first two examples, you can easily answer for the third example. You can able to understand clearly third, fourth, fifth and all. Consider it's a double word. Double word means two words are there. Two words means a single word consists of 16 bit. Then obviously two word is nothing but 32 bits. 32 bits. So nothing but 78, 79, 56, 57. The third example. Nothing but it consists of two words available. That is why it is mentioned double word S1DD. That means it will allocate a space of two word memory location. Similarly, DQ, defined quad word, 4 words. And similarly, the fifth example, DT, totally 10 bytes. You can see 00 is 1 byte and double one is last example I am talking about, 00, double one, double two. So everything 00 is 1 byte, 1 is another byte, 2 is a third byte, 3 is fourth byte, 4 is fifth byte, 5 is sixth byte, 6 seventh byte, 7 eighth byte, 8 ninth byte, 9 will be the 10th byte. So in order to mention the program, it's a 10 byte value. That is why segment 1 consists of dt. That means define 10 byte. So after dt, whatever the number which consists is nothing but as 10 bytes. Then in the next slide, we'll be seeing the next subdivision of directives, end directives, such as three types are there. In that end P, end S. End means it indicates the end of the program. After this line in the program, if you write any statement, it will ignore. That means assembler will not read that, will not execute that, it will ignore that. In the program we will see this where we are using in the program end. Then next one end p means actually the program is splitted as multiple sections. So in that we'll be having code segment, data segment, like that. Procedure segment also is there. The procedure is nothing but let us take an example of doing addition of two number. What we used to do, take two number as an input, add those two number and store it in the memory. This is the instruction. This is nothing but procedure to add two number, taking data and adding that and storing it in the memory. So this procedure part we will be writing as a program in the uh, assembly language. In this part, this addition part is nothing but procedure part. That procedure part, once if it gets end, we have to mention to the assembler that we have to give a direction to the assembler that the procedure is gets end. That is why end p will be mentioned in that portion of the program. Then end s is nothing but, already I told you, the program is splitted as multiple segments like code segment, data segment, procedure segments, all those things is there. In that end s means it indicates that segment gets end. That is why we will be using this end segment, end s. The next directive type is equate directive. Equate directive in the C program we used to mention as a global declaration. Global declaration means in the before void main we will be mentioning some values. We will be declaring int a equal to 20. That a will be used throughout the program wherever we want. That is why it is called as global declaration. Similarly, in the beginning part of the assembly language program in this microprocessor, we can mention like in the example in the second point I have mentioned PIC is equal to 7, nothing but PIC is equal to 7. So wherever I wanted to use that 7 in the program, I can mention PIC. So you may ask, instead of PIC I can mention directly 7 everywhere, but in the program I wanted to use that 7 for 10 times in various lines. Let us take 10th line, 20th line, 40th line, 50th line, like that. Multiple times I wanted to use that 07 in the program. So if I wanted to edit the program, that 7 has to be modified as 10 or 20. Then what I have to do, I have to go to that program line and I will change that 07 as 10 in every line. Let us take 20 times I have mentioned in the program 07. So that many times I should go and change it. So instead of that, instead of doing like that, if I mention this PIC EQU07H means, that means this 07 can be used throughout the program, like in the last line of the program, add BL comma PIC. Add BL comma PIC means BL value is something like 20, which will be added with PIC. PIC already I have mentioned 07. So what will happen? The 20 and 07 will be added because PIC is nothing but 07. If I wanted to change that 07 as 25, BL content will be added with the 25. With the 25, I will be mentioning in the starting portion of the program itself. So everywhere, wherever I am mentioning PIC, there and all that 07 is replaced with 25. So I no need to change in every line. Simply I will change in the starting portion of the program, which will be this kind of directive is used for the user friendly of programmer. Then we will move on to the next directive type, segment directive. Already I told you the program is split as multiple segments, code segment, data segment, stack segment, extra segment. Code segment is nothing but where you can write the program, nothing but that addition, subtraction, take two number, add those two number. These steps and all we will be mentioning in code segment. Data segment is nothing but where you can store only the input and output data, where you can give input data after the process gets end, like addition process or subtraction process or some other manipulations. Finally the answer will be stored in the data segment. It won't be stored in the code segment. And then stack segment, already we know that push operation, pop operation, all those things will be stored, those operations are stored in the stack segment. We know that call instruction and all will be used from main program to sub program. Once if it moves to the sub program, after reading return it has to come to the main program. For that case it should store the main program address in the stack segment. That is why push will be given, push that address, and then while after reading return, from jumping from subprogram to main program, it will pop the address from the stack memory. For that reason we need stack segment. The address will be stored temporarily in a stack segment. And then extra segment, if the code and data segment memory location is fully occupied, if you require more than that memory location, this extra segment can be used for code and data segment. Let us check why we need separate segments. Already I told you code, then stack segment, then extra segment, and then data segment. These are all various segments. Why they are splitted like that? We can see in 8085. This topic is under 8086, but this example is given for 8085. 8085 doesn't have this kind of segments, data segment, code segment, all those things. Then we will see what is the problem arising 8085. Here program memory address is given in the left side column and mnemonics is given in the right side column. LDA 4500. LDA 4500 means in 4500 some value will be there. That value will be loaded in the accumulator. And the program address in the left side column is mentioned 4000. That means in 4000, the mission code for LDA 0045, these are all will be stored from 4000, 4001, 4002. That we all understood this. But in case in example 2, let us consider that mnemonics LDA 4000 and program address also 4000. So in LDA 4000, so what it means, 4000 consists of the data for, let us take this program is for addition. So first data will be available in 4000. But in program memory address also we have given as 4000. So that 4000 will it consist of LDA opcode or the first value? This problem will arise as if you don't have a code segment and data segment separately in 8085. But this problem won't arise in 8086 because data segment consists of input and output data. Code segment consists of all the programs. So this will not disturb the program segment, will not disturb the data segment. Data segment will not disturb the code segment. Now we will see example program for directives, assembler directives. So let us take addition of two 32-bit number. First 32-bit number is 1, 2, 3, 4, 5, 6, 7, 8. Second 32-bit number is AA, BB, BB. So in this, first, if you do manual addition, what we used to do, that 5, 6, 7, 8 will be added with BB, BB. So that is why 5, 6, 7, 8 is mentioned as segment 1, S1. then BB is nothing but segment 2. These two I will add first. I will be getting a value called 1233, and with one carry, that carry I will add with that 1234 next number. So at present consider your answer is 1233, nothing but I will store that answer in S5. So first 32-bit number is what? 1, 2, 3, 4, 5, 6, 7, 8. Second 32-bit number is AA, BB, BB. So in this, I will split this 32 number as 16-bit and 16-bit. First 16-bit is nothing but 5, 6, 7, 8 and BB, BB. So that is why it is stored in segment 1 and segment 2. Then next 16-bit is 1, 2, 3, 4, AA. This will be added with the carry which is produced from while addition of S1 and S2. So with carry, I need to add 1, 2, 3, 4 and AA. I will be getting BC, DF. That I will store in segment 6. So segment 1 consists of 5, 6, 7, 8. BB, BB will be there in S2. Then segment 3 consists of 1, 2, 3, 4. And segment 4 consists of AA. So answer of this addition of 1, 2, 3, 4 AA will be stored in S6. So now we will see the program for title 32-bit addition. 32-bit addition in this segment 1 consists of a DW5678. This 5678 is nothing but one of the data. So that is why it is stored in the dot data segment. Why we are mentioning data? Because after this data, whatever we are going to see, that and all input data, and the question mark here I have mentioned in S5, S6, there only we going to store the answer. At present we don't know the answer, that is why it is mentioned as question mark. And the S2 contains has to be contain BBBB, but why it contains 0 BBBB means why it starts with 0 means the number starts with the alphabet called B, but the machine will not understand whether it is a instruction or a data. Actually this BBBB is a 16-bit data, but the machine will not understand it is a 16-bit data. So in order to mention that is a 16-bit data, not the instruction, we have to mention 0 before before the BB, and then DW already we know that DW is nothing but define word. Define word is nothing but after DW whatever it comes, it is a 16-bit number, otherwise called as one word. Then similarly, here what is the mistake you can identify is that in S4 DW 0 I have not mentioned. Actually 0 has to be mentioned. That is correct answer. 0 we have to mention because it starts with alphabet. In order to mention this is a 16-bit number, we have to mention 0 we have to mention before that alphabet number. But 0 is not required in segment 3 because it starts with a number. So it will identify it's a 16-bit number. But if it starts with the alphabet, we have to start with 0 in order to mention that is a value. And already I told you S5 and S6 is allocated for answer. And once the data segment over, code segment already I told you here the program will be there. Coding is nothing but programming. Here main procedure PROC, so procedure part going to come. So end P we have to use in order to mention at the end of the procedure. Procedure is nothing but taking the first data, moving it to, you can see in the fifth line, segment 1 first value is there, that I will move in the accumulator AX. AX is nothing but a 16-bit accumulator register. Then S2 is uh, S2 is other value. S2 is a segment 2 value where you have BBBB that I will store it in the BX. Again, BX is a 16-bit register. So first value 5678 will be loaded in AX, and BBBB I will load it in BX, and then now I'm going to add AX comma BX. So AX contains of 5678, BX contains of BBBB. So these two will be added, and the answer will be loaded in AX register. Then that AX content will be moved to S5. Already S5 is for storing the answer. Already we have allocated in the data segment. Then comes to the next value 1234 is there in S3, that will be moved to AX, and then AAAA will be available in S4, that will be moved to BX. Again, now it is not ADD, it is ADC, nothing but add with carry. Add with carry means while adding 5678 and BBBB, we will be getting a carry. That carry has to be added with the next 16-bit addition. That is why here add carry ADC AX comma BX. Now these two will be added with the carry, and the answer will be loaded in AX. That in the next line it will be moved to the S6 segment. So and then this move AH4CH into 21H and all for execution of the program. This will be default lines in all the program. But according to the assembler directive topic, we need to know the next line called main end P. Here end P, already we have seen this in end directives. End P is nothing but the procedure gets end. We have to indicate that the procedure gets end. Already we have seen that addition procedure gets end, and end main means that main procedure it's get end. That is why this assembler directives are used. Thank you, students.